Alrighty. Good morning, everyone. I'm Hamish Watson. Welcome to the DevOps virtual group. This morning, well, I say this morning, it's 4 a.m. here in New Zealand, where I'm hosting, and yes, this is what I look like at 4 in the morning. This morning we have got a special session because the 9th of July, as everyone knows, is when SQL Server 2008 R2 go out of support. So we have a really cool session that's being brought to you today by Pedro Lopes. Pedro is a senior program manager in the database systems group with a focus on SQL Server's relational engine and programmability space. So yeah, without much further ado, I'm going to hand over to Pedro. Just remember, we have the questions app in the GoToWebinar control panel. So if you have any questions, please put them in there. And what we'll do is, unless it's a pressing question, we'll do the questions at the end. But Pedro, over to you.
Thank you. Well, good morning, afternoon, or evening, depending on where you're listening from. It's 9 a.m. here, so I'm a little bit better than you are. So welcome, everyone. This is a day that's been long coming. For 10 years, actually, it's been announced. It's the official end of support for SQL 2008 and 2008 R2. I've actually, at 7 a.m. Pacific time this morning, I've put a blog out there talking a little bit about this and what options you have, even if you need to remain for some more time on SQL 2008 and 2008 R2. So I would encourage you to go to the SQL Server team blog and kind of read that one. On that note, our session today is about upgrading or modernizing SQL Server, and what process and tools do we have that have been tried and tested in the field with many customers to get to a point where it's very much streamlined and we know it works and we know it can bring value and efficiency to your upgrade process. So this is a rough agenda here. Why upgrade? The usual motivations that we see, obviously end of support being one of them, but if you're in SQL 2012 or any other version, then obviously end of support is not necessarily the motivation, but there are others here. I want to talk about database compatibility certification, and then going through the upgrade process itself and what tools we have to aid in the upgrade process at every stage, and talk a little bit about post-migration because as we see it, after the data has moved and you have the actual cutover, the migration window is not closed yet. There is some more actions to be done and some more monitoring to be done, and that's important to understand. Okay, so why upgrade? These are the usual types of questions that I would say you would ask yourselves if it's the right time to modernize, because this is also the kind of questions we get from our customers all around the world. Maybe your requirement is to modernize your SQL Server infrastructure to reduce costs, maybe going to Azure, for example. Or like today's with SQL 2008 and 2008 R2 going out of support, is it to maintain compliance? Maybe you are in some industry like banking, for example, that requires you to be supported, your infrastructure and your vendor applications, including SQL Server, to be supported by the vendor, in this case, Microsoft. And that's the only way that let's say, the National Banking Authority would allow you to stay in business. So that's a compliance issue right there. If you're an ISV, actually, can you enable choice for your customers? Can you allow them to go to cloud or stay on premises, depending on their own goals, while using your application? And so, as you may have observed, we released SQL 2016 about 24 months after 2014, and 2017 about 16 months after 2016. So the cycle that's observable here is that to meet market demands and the pace of how database technologies move, we have to shorten development cycles. Now, it doesn't really make sense that a customer would have to wait for 2 years or 3 years to see innovations coming their way in SQL Server that have already made their way through Azure SQL Database, for example. So these are some of the fundamental questions that we have asked ourselves, and many customers have come forward as their motivations to the questions they ask to understand if it's the right time to take that step and move forward to either replat or so replatform to the cloud, for example, or remain on premises and leverage their data center investments, but modernize using what's there already. So yeah, this slide doesn't really apply anymore because today is the day that, as I mentioned, SQL 2008 and 2008 R2 are going out of support. By the way, if that's a question in your minds, because I've gotten that recently quite a bit, why is 2008 R2 going out of support at the same time as 2008? Because SQL Server 2008 has been around since July 2009, but the SQL Server 2008 R2 has been around since 2010. The reason is that they both share the same major version. And this is actually the first and only time this has ever happened in the history of SQL Server, that two named versions, so to speak, share the same numbered version, which is version 10, which is why the life cycle is the same for both of them. Okay, so I want to talk a little bit about the notion of compatibility certification here. And this has very much to do with the way we operate in Azure, and the fact that I would like to call out that we have literally the same database engine powering SQL Server and Azure SQL Database. So I would submit that any certification process should be thought in terms of which compatibility level am I certifying to, rather than which named version am I certifying to, or am I certifying on premises or versus cloud. And I understand this is a paradigm shift that may take some use to, but it really unlocks some agile modernization cycles and can reduce the upgrade risks. So the ability to move in a very friction-free way between SQL Server on premises and the cloud with virtually no code changes is a very powerful idea here. And this is actually the way we are able to really continuously release new features and upgrade essentially our Azure SQL Database infrastructure, including the code base, and not break customer applications. Now, as some of you may know, in Azure SQL, we have a continuous deployment model. Roughly every month, we are deploying out there a new version of the database engine, and that is happening while roughly 3 million databases are in production on top of Azure SQL Database. And how do we keep ourselves from breaking those applications if we introduce a new feature in the query optimizer, or if we introduce some change in the way that query processing is done? That is precisely about compatibility and compatibility levels. So the idea of certifying an application to a compatibility level rather than a named version is powerful. And it actually has been happening for a long time, because if you've tested and certified your application or a vendor application that your company uses on a given named SQL Server version, for example, SQL 2008, it's actually nothing to do with SQL 2008. It has to do with actually the code base that existed at that point in time. And the version of the code that existed at that point in time in what relates to functionality of Transact SQL code and performance by ways of the query optimizer version, those are all locked behind the setting that existed for a long time, which is a database compatibility level. Now, that means that you've implicitly certified on that compat level and not on a named version. And I understand this is a paradigm shift, because we, Microsoft, have been pushing for many years that we just push the names of the product. But in actuality, the technical truth is that it has to do with a version of the binaries and a version of the code, and that, like I said, is gated behind the DB compat level. Now, that also allows you to reduce upgrade risks. For example, in this day and age that we are looking at, customers still moving from 2008 and 2008 R2 to a more modern version of SQL Server, or even contemplating going to a cloud vendor. The ability to reduce risks, for example, by separating the points in time where you can and should move the application code from the database layer, that can create, this approach can create less disruption. For example, I've been involved in some large ERP migrations where historically you need some downtime because it's imperative that you move the database layer at the same time that you move or upgrade the application layer that supports it. Now, this can be a problem in the sense that there's a lot of moving parts at the same time, and usually it's a more extended downtime. Now, think about a scenario where you can actually maintain the application as is, upgrade the database engine to a more modern version, for example, SQL 16 or 17, keep the same database as is, and so the only moving part in this scenario was the database engine. And as you point your existing application to that new SQL Server that has a newer version of the engine, but it keeps the database as is, as it came from the source system, then you are actually testing and then running on a new version of the engine and leveraging capabilities like scalability enhancements that we put into the engine that are not dependent on the version of the database compatibility level. Now, this allows me to, for example, if there are any issues during this time, I know that the only moving part was a database layer, and I can address those with the database vendor, for example, Microsoft. At a later point in time, when I've stabilized this, I can then plan to upgrade the application layer. And then if there are issues coming from there, then the only moving part at that point was the application layer. So most likely you'd have to troubleshoot starting from there. Now this reduces upgrade risk because now you have more focused areas of the upgrade, and it's a phased upgrade that you went through, and therefore you have more control over it. Now the ability to upgrade to the latest database engine or move instances to the cloud with no code changes is a real value prop here. Because we have a number of tools that will allow you to determine the surface area, and I'm going to show them today to understand if you are ready to move with no code changes, or if you are coming from a really, really old version and you have a really, really old code base in your application that may need some changes. We have tools that will show them, that will show you what has to change, and therefore you can have your development teams or yourselves, obviously being DevOps, do the required work to make sure it works. So we fully support this notion of compatibility certification, and we've done so not only in the code. We run that ourselves every day in Azure, like I mentioned. That's the way we are able to continuously deploy to Azure and not break applications. So this is not just Microsoft talking the talk. This is actually we walking the walk. We do this every day as running our own DevOps environment, obviously. So we provide an ecosystem of tools and actually services to test whether this notion of compatibility certification is the right for you and for your specific application of database. And by the way, there's a URL in the bottom of the page there, aka.ms WAC compat. You can read a lot more about the technical intricacies of this compatibility certification. So a couple of points I'd like to make here. One, the compatibility level protection allows you to maintain backwards compat. And this is, like I said, something we do every day in Azure. Applications running on a newer version of the database engine, but if they're mapped to an older DB compat, they will leverage those behaviors that are specified by the DB compat, but they can still use server level enhancements and scalability enhancements that we've done to the engine itself, even without the application changes. Now, that also means that we have a level of predictable performance, because like I said, we gate every query optimizer change behind that DB compat level. So that means that your queries are optimized and therefore executed the same way that they were in a given source system, because precisely you have mapped that database to operate on this DB compat level that locks down behaviors to a given code base. In this case, could be SQL 2008 or version 10. But all of this is, we're not asking you to necessarily take a leap of faith, although we do this every day in Azure, like I told you. So this is tried and tested. But we provide you validation testing tools, like the Data Migration Assistant, that can go through your database schema, but also now through your ad hoc application code, so code that is sent by the application to the database without necessarily being inside store procedures, functions, and whatnot. And we can validate those results to understand if you have a green light and you have no changes to your code that are needed in order to move to that higher version of the engine, or B, if you have some, we will point out which ones they are. So, and just to give you a visual aid here, see that historically and up until SQL 2014, our stance was to keep the latest DB compat, which mapped to the named version of SQL Server, and keep the two previous levels of DB compat. So, for example, in SQL 2014 here, that was when we released DB compat level 120, and we still kept the DB compat for 110 and 100, meaning SQL 2008. Going forward with every version, as you can see here, we have stopped removing the older DB compats. And that's also because we have changed our stance in what relates to deprecating database features. We have stopped deprecating database features starting in 2014. And the only ones that we may reserve ourselves the right to deprecate, and obviously document those, will be in case they are actually in the way or impeding a breakthrough, a technology enhancement in the database engine itself. So as much as possible, I usually say that the unsung hero and the undocumented feature of SQL Server is the obsession that our teams have with maintaining backwards compatibility. And that is seen here, because as you can see in the right side of this table, SQL Server 2019 and Azure SQL Database are now supporting DB compat level 150, but they support all the way back to the SQL 2008 timeline, which is DB compat 100. So you can run your database as is, and therefore without code changes, maintaining DB compat 100 in both Azure SQL Database and even SQL 2019, obviously 2017 as well, and 2016. So this is really important to keep in mind, that these behaviors that can affect your database performance and the behavior of your applications are gated. And as long as you consciously maintain that gate until you have tested if you can go beyond that gate, then you are protected against the risks that usually come with upgrading. Okay, so let me just give you a couple of very quick examples of this functional change protection. And I want to clarify a few terms we have out there in the documentation that sometimes generate some confusion. So, for example, the concept of a breaking change. We have, throughout every version of SQL Server, we have a page that lays out, and it's getting increasingly empty, by the way, but lays out the breaking changes between versions of SQL Server. These are potential changes, all of them documented, obviously, that for a given piece of code that it still can execute, there may be some behavior change that results in a different output. And this means, for example, look at this example that is protected by DB compat. Look at this specific query here. I am casting this variable, which is datetime, as a datetime2, so a conversion must happen. With SQL Server 2016, and that's fully documented, we have increased the precision of datetime to date type. Now, that means that this kind of conversion, up until the release of SQL 2016, used to work like this. So therefore, when I say SQL 2016, I want to start mapping the named version to the DB compat levels, because that's the real certification that happened here. Up until DB compat 120, this was the outcome. And let's say that you have some query that does a equality predicate that has a equijoin, for example, and this query based on this value has a certain number of results. Now, even in SQL Server 2017 or 19, if I maintain DB compat 120, I maintain the legacy behavior. But if I move to a DB compat 130 or above, because like I said, we have improved accuracy by accounting for the fractional milliseconds, this is the result of this cast. So as you can see, different. Now imagine that your application has some equijoins, for example, on an example like this, and suddenly the result of that query, the result set changes because the comparison predicate changes, right? So it is very important that you look at DB compat as a way to lock down behaviors that existed at the time you certified your application. And this is such an example. Now, another example has to do with discontinued, a breaking change that is not protected by DB compat because it's discontinued. For example, back in SQL 2005, so this is really, really, really old, and I actually couldn't find any example that's not protected by DB compat. That's more recent, by the way. So that's why I'm going so far back as 2005. SQL Server 2005 DB compat was 90. That's not even supported in SQL 2012 and above. However, look at this query. So in DB compat 100, which is the minimum in SQL 2012 and above, because it mapped to SQL 2008, this query that may work well back in 2005 was already broken. So you would need to instead use one of these two variants in order to achieve the same output. So if you have a really, really old application, the DMA tool that I'm going to show later can come. Let's say you're upgrading from SQL 2005, and that tool can still point to 2005 or 2008 to the 90 compat mode. It will show you and really report on this type of issues that are not protected by DB compat and tell you, hey, these are the solutions that you need to go and actually do a code change. So what I mean to say with this is that if you have a really, really old application that is still working with SQL 2000 or SQL 2005, we have, and perfectly documented again, but we have discontinued a number of database features, including language features. So you may encounter issues that the DMA tool will report on. However, if you have a more modern application, let's say that was born in 2008, for example, and so we're talking about changes in behaviors that have been put forward into the engine after that point in time, then those are all protected by DB compat. So it's important to understand this. Now, just a couple more other terms that I'd like to clarify is the notion of deprecated and discontinued. These are completely different. So deprecated, if you see a feature that is deprecated, that means that, yes, it still works, but you should avoid that in any new application development, because that means from the get-go that that feature being deprecated is not being looked at regularly, which means it has no roadmap, and it may potentially one day be discontinued. That means removed from the product, as you see in the second bullet point. And like I said, if it becomes a blocker for us to actually advance the database technologies that we have in SQL Server. So it's important for you to understand these two terms. Okay. Oh, and just an example of remove T-SQL syntax. And this is the last time we actually removed T-SQL syntax was back in 2012. The hint fast first row was actually removed from the product. So that can't be protected by DB compat. However, the tools that will find this will also provide you with an option to go and change your code. where the query that you were using, the fast first row hint, you can now have the hint fast equals an integer that you can specify the number of rows to produce more rapidly in the result set. Okay, so what about new DB compats? For new development work, or whenever your application needs to use newer features in the query optimizer, for example, all the latest features we have in intelligent query processing, like adaptive joins and memory grant feedback and others, those are again gated in higher compat levels, so they don't affect legacy workload in ways that could be unforeseen, for example. So we want to really make sure we have an ironclad, bulletproof way for you to upgrade and even gate you from some newer features that could produce good outcomes. But even good outcomes are changes, and we want to prevent changes until you're ready to do so, which is why it's so important to maintain DB compat when we move to higher versions of the engine. Okay, so given this, let's move on to the upgrade process itself. And these are really important concepts to keep in mind, the ones we've been discussing so far, because there's a lot more literature that you can go read on those. But it's really important for you to know that you can move today, and you don't necessarily have to move to the latest DB compat. You can keep it as is, and that's already, for example, a way to maintain your old SQL 2008 databases completely supported in, let's say, SQL 2016 or 17 or even Azure. As long as you keep the same DB compat, you are not incurring in behavior changes that can impact your application results, or in performance changes that can negatively perhaps impact your performance, because we have gated all of those. Okay, so moving on to the upgrade process itself. I'm not going to dwell a lot, apart from this slide, on the upgrade strategies themselves, on the data movement itself. These are some of the most popular ways to move data. Log shipping, typically the cutover is minutes. So if you have a fairly low downtime window, but it can still take a few minutes, this can be a way to move data and then do the cutover. Replication, transaction replication is more cumbersome to put together for an entire database or a number of databases. However, the cutover is usually measured in seconds, so that can be an option. Backup and restore, well, this is the simpler way, but it's also typically the way that takes longer, because it's simpler because you take the last backup, you shut down the application, restore on the other side, and then point the application to the new server, and you have no loss no pre-planning, I mean, in what relates to having to do cutovers and data syncs and whatnot. Then more or less the same goes with file system or SAN copy, although SAN copy is much faster than doing a file system file copy, obviously, over the wire. And finally, you have availability groups, which were not available before SQL 2012. And the cutover is also measured typically in seconds. It's much easier to put together than replication, because you are essentially replicating the entire database instead of just some articles, and allow you to have this cutover also to be very low in terms of time. Now, the rest of this presentation is not about the way to move data, but rather the overarching process of performing a migration. And we start with so this schema that you see here is the result of a lot of migrations that we have run with our customers, and it's actually what we have in the Azure Data Migration Guide, for which I have the link in the last slide. You can actually, from that site, build your own migration guide. You can choose where you're coming from, SQL Server, SQL in AWS, or another Oracle or whatever, and you can choose your destination, SQL Server, SQL on Azure, whatever, and it creates a personalized migration guide for that scenario specifically. This is the overall steps that exist in that database migration guide. And we start with the first step, which is the discoverability part. Now, to do reliable upgrades and to be able to run through this entire process, we provide a number of fully automated tools that are free. And we have tools that support the discovery phase, for example, the Microsoft Map Toolkit. And this is an inventory tool. If you have your own, obviously you don't need this. But the first step into a migration process is understanding what's there in order to plan how to move it to another platform or another environment. Then it's the assessment phase. You need to understand where you sit. If you are completely risk-free and you can move at will, or in the very few examples that I gave earlier, do you have any very old code base that may have some blockers that preclude you from moving to a higher version of the engine itself, even maintaining the beacon path, because that T-SQL may no longer work. So it's important for you to know this, and that tool allows you to get that. Or maybe you also need to pre-test the performance that you can expect from your workload in the newer version of the engine. And the Database Experimentation Assistant, or DEA, is an A/B testing tool that allows you to run the workload in your source system, let's say the legacy system that you're trying to upgrade, run the same workload on the same database as is in the newer version of the engine, and then provide you a report, and you can do this in a test server, for example, a test environment, and it gives you a report that shows you where you had performance regressions that you can go preemptively fix and tune before you actually put the application in production. And it also tells you what's better, just for the sake of moving to a new version of the engine and no changes whatsoever. And it can actually also tell you if there are migration blockers. Let's say if some code stopped running, and that comes up as an error in SQL Server, obviously. It can also very specifically point out if there were errors in execution. So we had Salesforce, for example, is just one customer that has used this process and this tool ecosystem to be able to move around 1,000 instances of SQL Server in just 3 months. And obviously, with each instance that they moved and they ran through this process, they were able to automate all these tools, automate them into a single work stream, and it got very fast for them to be able to achieve this. It's a really impressive number, 1,000 SQL Server instances in 3 months. And they use, for example, the A/B testing capabilities of the DEA tool. And that's super important to understand which performance to expect of the target, the destination SQL Server. So we start with the discover phase. And the discover phase is basically about inventory. You need to know which SQL Server versions you have, which editions you're running, which other components out of the database engine that you have installed, and you want to know how many databases you have in each instance and the size of those databases, because all of those, especially the size, will impact the strategy you use to move the data itself. So to be able to discover your environment and to have an inventory, we provide this free tool, the Map Toolkit, that assesses the cloud environment, desktop, server. It can have these are the few of the scenarios that you can assess: readiness to move servers to the cloud, or readiness to virtualize servers, or in our case specifically, database assessment, which is what you would run as a discovery in the Map Toolkit around your environment. You can see here in this screenshot that we found in this environment 3 SQL servers. One is 2008 R2 and 2 are 2008. And we also found 2 Oracle 11 instances and 1 Oracle 9. So you kind of understand exactly which databases you have in your overall environment. Then you move on to the assess and convert phase. Now, the assess and convert phase is where you'll use the data migration assistant. And this is probably one of the areas that you'll spend a little bit more time, because you really want to understand your readiness to upgrade. So the data migration assistant will allow you to assess compatibility issues, see if you have breaking changes, So if you have breaking changes, as long as you keep, I've given you a couple of examples of a breaking change that is protected by Dbcompat and one that is not, because it's coming from 2005 and it's very, very old code. It can assess behavior changes and even deprecated features. Now, as I said, deprecated features doesn't mean that the feature was discontinued. So you can continue to use that in the newer version of the engine. It's more like awareness that, hey, you're using these deprecated features in your application code or in your database code. If there comes a time when you have a project to upgrade and kind of modernize your application design and your database design, please look at these deprecated features and plan to move them out, meaning to upgrade that functionality to something that is not deprecated. Then it also allows you optionally to discover new features. And we have a number of new feature discoverability. For example, you can point to a database and it can tell you that, hey, you have these tables here that seem to be appropriate for you to create some column store indexes or to move to in-memory OLTP, for example. So you can have new feature wizards that help you discover opportunities to leverage newer features in the engine that are not gated by Dbcompat, by the way. And ultimately, it can still allow you to perform the migration itself, although typically in these very large environments, that's not the way that's usually done. Data Migration Assistant, what it does is it only supports backup and restore. So it's probably not what you want to do in an environment that requires very low downtime, like seconds or minutes, in which case you would go with one of the other options I've shown. However, if you run through, if you plan to do let's say a tier 2 database migration using a backup and restore, you can still do that inside the DMA tool. These can also, by the way, be automated. These support scripting because they all have command line options. So you can, that's the way that Salesforce, for example, automated all of these. And again, Salesforce coming in because they did use the data migration assistant to understand potential pitfalls and automate some of the remediation that the development teams were able to act on before that database was migrated. And therefore, when the migration was done, it was done literally risk-free because they knew what had to be fixed or not fixed before doing the move. I want to show you a quick walkthrough. So I don't have a full-fledged demo, but you can go and download the DMA tool. I'm going to do a quick walkthrough of what you should expect coming from that, because the assessment results I'm going to show took some time to put together. So I want to be respectful of our short time window for this session and just move along. So just a quick note here that the latest version of DMA, version 4.3, now includes ad hoc workload assessment. Up until version 4.2, the DMA tool could only assess the readiness of your database schema. So only if you had your store procedures and functions and whatnot in the database, and the application was using those to generate the result sets, then the DMA tool could assess those. But if, for example, you're using some code generation or an entity framework or something that generates ad hoc code and sends to SQL Server, then your schema doesn't hold the code that your application uses. So the DMA could not assess that up until this version, v4.3. So very quickly, this is a project-based tool, the DMA tool. So to get started, you create a new project, as you see there. And then in this case, I'm going to create an assessment project. And you can select a source type, which can be SQL Server or RDS. And then you can also choose a target type, which in this case, I'm going to choose SQL Server, but you have all these other options available here. And that is tailoring the analysis to this specific data motion. So then you move on to to selecting the types of tests you want to run. So I'm just selecting here compatibility issues to discover those breaking changes and behavior changes and even deprecated features, right? But I could also optionally select a new feature recommendation, in which case I was going to look for opportunities to create column store or in-memory LTP or a number of other features that can improve performance and security of a database but I'm opting out of those here because the target, the specific scope of this is to determine if I have upgrade blockers. So I'm just choosing compatibility issues. Clicking next. Oh, by the way, I could select the target version here because I chose SQL Server. Then I can choose these SQL Server versions as a target. And obviously, I only have the supported versions right now, so SQL 2012 and above. So after I select the target version, I need to connect to my target instance. In this case, it's a SQL 2008 R2 instance. And once I connect, I choose the database, and notice there in the bottom right quadrant, I can actually point also to a folder that contains the files, the event trace files that can be either server-side traces or X events, in order to also assess those and bring that result into my consolidated report. So at the same time, I'm analyzing both the database schema on my AdventureWorks database and whatever ad hoc workload that I captured in my trace. Okay, and after I run the report, which may take some time, this is what I get. So I see, hopefully you can see the screen well enough. I'll try to bump it up a little bit. There we go. So you can see that it's organized by DB compats. Now, this is a SQL 2008 R2 instance that was running in compat 80. And that compat 80 was still available back in this version of the engine. The minimum version that exists in my target SQL Server, which was in this case SQL 2017, is 100, which maps to SQL 2008. So this database, once it moves, it will get automatically updated to the minimum DB compat, which in this case is 100. Now, for the DB compat 100, I have 10 issues I need to look at. Not all of them necessarily have to be fixed, because deprecated features are also listed here. But if I actually want to move all the way to the latest DB compat available in SQL 2017, which is 140, I have 14 issues I need to look for. Now, I get all the detail here. I have 8 breaking changes. So these I definitely need to take a look at, because these are features that need to be replaced, or they don't have the same behavior. So therefore, I may need to maintain an older DB compat. I have behavior changes as well, and I have deprecated features. If I click on any single of these issues, I see here the issue details. I have more information on those issues, and I have which objects are impacted by that issue that I've clicked on. In this case, if I click on this store procedure, it tells me the name of the procedure, and it tells me that the specific DPCC command is discontinued. Where? It's in line 5, column 9 inside the procedure code. So it even maps to me where I should go and literally find the code that needs to be changed. And it tells me here, for example, that I need to, if I have a DBCC DB index, I should change that with an alter index. Or a DBCC show config, I need to change that with this, calling this DMF, and so on and so forth. So I have all the recommendations here that I can go act upon and fix those issues, especially these breaking changes, before I'm actually able to move the database. So I have all that comprehensive understanding here. Now, once I know what needs to be fixed to convert, now it's the time of the process that you probably will spend more time on, because it's a rinse and repeat cycle in your testing environment or in pre-production environment until you are ready to move onwards. This can all be automated like Salesforce did, obviously, but this entails remediating application issues that we may have found, running functional performance tests specifically on and this is especially useful if you have unit tests that can test those areas of the application that were mapped to functional issues that the DMA tool raised. Then you may also have the opportunity to optimize. For example, if you have also brought in the inputs from the optimization assessments, which we haven't used in this specific demo or walkthrough. And then once you've done that, then you migrate the schema, objects, and data. So this may be where you take the longest in your migration. Now, to be able to test and optimize, we also have another tool that is free that we allow you to use, which is a database experimentation assistant. This is primarily an A/B testing tool. So as the name suggests, it's to test the how the specific workload did in the source system, which in my case could have been the SQL 2008 R2 system, and now the same database or set of databases for that same workload in the SQL 2017 system. And it can bring out compatibility execution errors. So that will be another layer, if you will, of understanding if there are execution errors. Although, like I said, in the latest version of DMA, DMA also does this ad hoc workload assessment. But if you were using an older version of DMA that did not have ad hoc workload assessment, only static schema, then the DEA tool would still allow you to submit an ad hoc workload to it and still get potential upgrade blockers. Now, the real power of this A/B testing application is the ability to give you the degraded queries if you find some. Also, there's workload comparison per query, and for the entire workload, it tells you what performance metrics you had in the source system versus the destination system, and that allows you to understand, hey, is this a good investment of my time as is? Or do I need to actually go tune something before I do the cutover because I have a performance drop? Hopefully not. So again, this is part of the tool set that Salesforce used, and they were able to understand and identify regressions and performance characteristics of the workloads as is in the newer systems before they actually moved. And that is super powerful because you can, for example, have the confidence to say, if I move this database and its workload as is to this new system, this is how much performance enhancements I'll get for free just for the fact of moving, not even doing anything, any specific tuning in the database. So let me also run a quick walkthrough of this DEA tool to see for you to see what you can expect from here. It's again a project-based tool, so it does essentially these three things. Oops, sorry. Oh my God, hang on. I'm getting this back. And there you go, coming up. So it is oh my God, this is not working out for me. Sorry, let's try this again. I know what happened. I didn't have the scope correct. There you go. So what it does is it captures a workload on the source server. It will then, so this could be your production server where you capture the workload there. And then you can, through this tool, replay that workload against target one, which could be my SQL 2008 R2 in test environment, and my target two, which could be my SQL 2017 in the test environment. And then what it'll do is it will analyze those replay traces and come out with a comprehensive report that shows me where I'm at in terms of performance and workload characteristics in the newer version of the engine. So, and the leopard keeps coming back. I'm sorry about that. There you go. So once the thing I need to start is I connect to my server to be able to collect the trace, and this will be my production server. Then after I run through that, so I've obviously skipped to the end here. The steps are those I mentioned. You collect a trace, then the trace is run against target one and then against target two, and in the end you have this A/B comparison. In this case, look at the characteristics here. I was comparing a SQL 2008 source with a SQL 2016, so target one and target two, and these were the versions that I was comparing. These are the workload traces, and now it tells me information about my overall workload and what improved, and actually what degraded as well. So for the entire workload I've captured, 70% improved just by moving to a new version of the engine. Now I also had almost 28% that degraded. And each of these I can click and open sub-reports that tell me exactly what those queries are, so I can go pick them up and tune them. Tune the query or tune some underlying index design or something like that. It also tells me, so this was by execution count, this is by distinct queries. So I can see that a lot of my workload improved just by the fact that I moved the same database as is and the same workload running, just for the fact that it's running in SQL 2016 rather than 2008, it just improved. Now, I can also see a number of other important information. For example, do I have upgrade blockers? And I do have some here. I found 10 upgrade blockers. And these are the error IDs, so these are all documented, by the way. Error ID 156 has to do with not being able to execute some T-SQL statement. So obviously, this is some T-SQL statement that could not execute in the new version in 2016, but could execute in 2008. And I see here the top improved queries and the top degraded queries and on a number of metrics on them. Now, I can also, like I said, look at the upgrade blockers themselves. So if I click on upgrade blockers, I get this detail here. I know exactly which queries add an error, and the error is 156 because that has to do with incorrect syntax near the keyword compute. So these queries are using the compute keyword, which cannot be used as is in newer versions of the engine. The behavior changed here. So this query could not execute. So what I have to do is, the workaround is also fully documented, so I can just go and refactor these queries to run to generate the same result set without using the compute keyword. And once I fix these, my database is able to move to the newer version of the engine. So this is what DEA allows you to do. Now, once you do the data sync and you do the cutover, then you enter the post-migration stage. At this point, your application is pointing to the new database server with the database running there. Everything executes, everything is fine from a functional standpoint. And now you do the cutover. But once you do the cutover, are you done? I would submit that you're not. And the migration window isn't done by cutting over to the new server, but rather only after you understand if there aren't any latent issues in the new server as the workload, the production workload, starts executing that. So the post-migration step is very important to reconcile any data accuracy issues and to uncover performance issues with the workload. So here's, and you can stay there as is if you keep the DB compat. But let's say that at some point after you have this application in production, you want to start leveraging newer features in the database engine that are gated by DB compat. For example, adaptive joins and all the other features in intelligent query processing. That means that you would have to upgrade the DB compat level to the latest available. You can run with the old compat level for years. We don't care from that perspective. It's fully supported. If it works for you, and because you only have the need to upgrade the engine, maybe leverage some scalability features in the engine itself, but you don't want to retest your application in any way, then you can stay running in the newer version of the engine, even Azure, keeping the same DB compat as your source system. In this case, my 2008 R2, which had 100 compat mode. And I'm fine with that. This scenario, however, is when I'm at a later point in time want to really upgrade that DB compat level. So this is the recommended process to do that. You move the database to the latest engine and you keep the source DB compat. You already did that. Enable query store. Query store is like a flight recorder for your workload. So you really want this to understand what's going on. You will wait for it to collect a baseline with your production workload running on top of it. Or if you have a good test workload, you can run all this in your test environment. Then you will, at a certain point in time, when you satisfy that you have a good baseline, you will bump up DB compat to the latest, or whatever is your target, and then quickly fix regressions by forcing the last known good plan. Now, this offers you a choice. I have a plan that may have regressed after I bump DB compat, so I'm reverting that one specifically to the older model, and it works. And why is that? Why do we have these? This is one of the main risks of upgrading a server. Is not the server itself, but it's rather updating DB compat, which is why it's so important to run through that process. Which is why it's so important for you to keep in mind that you can. I correct that. You should keep the same DB compat as your source system once you move the database. Once you backup and restore a database or attach a database in a newer version of the engine or even Azure, the DB compat does not upgrade by itself. It remains the same as your source system. This needs to be a manual action taken at some point in time. Now, like I said, one of the risks of upgrading has to do with automatically changing DB compat as soon as you move the database without taking any precautions, and that can lead to very bad results in case some part of the workload starts regressing. And why does it regress? And it has to do primarily with the cardinality estimation process of the query optimizer. So we use cardinality estimations to generate optimal query plans. Now, most systems will benefit from these enhancements in the cardinality estimation process of the query optimizer because it's more accurate. But sometimes when you migrate from an older SQL Server to a newer SQL Server, you encounter the risk of performance regression, which is why it's so important to keep the DB compat as it was and follow that process that was in the previous slide. So why do I need query store? The query store, like I said, is a flight recorder. And one of the things that it does is can show you regressed queries. So you can actually see if you have regressed queries after you've bumped up DB compat. It also, in SQL 2017, the query store works together with another feature, which is called automatic plan correction, to identify if a certain plan has regressed, and automatically it will revert back to the previously known good plan. Look at this timeline here, and there was this plan active for a given query in these time slots, and then there was a recompile for some reason, and the new plan regressed. Or maybe it was at this point in time that you bumped up DB compat. So this is running with the older DB compat, and then you bump DB compat, and this query regressed. Guess what? Because you've built this baseline, this feature is able to automatically detect that this regression happened. It detects that it had a good known plan before this kicked in, and it will revert back to that one automatically. So this will allow you to, for example, bump DB compat after you've built this baseline. And if something regresses, it's automatically dealt with. And guess what? You didn't have to be on call in the middle of the night or at 4 a.m., like my poor friend in New Zealand, having to perhaps fix a production issue because this was taken care of automatically. Now, we also have a newer tool in the arsenal, and I know I'm very close to being done, so I'll skip the demo, but you have the demo available in our Tiger toolbox. We have a newer tool in this upgrade arsenal to guide you through that upgrade process that you've seen before. And that's the Query Tuning Assistant. The first priority, and the only priority of the Query Tuning Assistant, is to guide you through that documented compatibility upgrade procedure. But, and this is the process that we've seen before, it will guide you through these steps. However, in the last one, instead of using something like auto-tuning to correct the plan and go back to the one that existed in your baseline, it will actually try to find a third plan, a better plan that leverages what's better in the newer version of the engine, specifically the cardinality estimation, but still work better than the regression that you obviously had. So this last step is actually replaced, and instead of going back to a less known good plan, it will find a better plan through some query tuning. So this is a tool that is client only, so it's available in SSMS, V18 or above, and it does also use Query Store, specifically the ability of Query Store to identify regress queries, which you can look upon in that report that exists in SSMS. But what it does is it will take those regress queries, it will analyze those regress queries, it will only pick up selects, because those are the ones it can actually analyze and collect runtime information on. And then, because these four bullet points here are the ones that, according to our experience, are the most common reasons why, in the case of a workload regresses after a DB compat bump, why it would happen. So we will test these scenarios and try to correct them using hints, as you see that here on the screen. And if that hint is effective, then it will be shown in the end of this process as a recommendation for you to do. In which case you can do it yourself, or there's also an option for you to implement it. So the deployment of this hint will be done through a plan guide created for that query specifically. Now, I won't have time to do the demo because we're at the top of our hour. However, this feature, QTA or Query Tuning Assistant, is fully documented step by step with screenshots, and you can Google it or Bing it, and it will take you to the page. Also, in our Microsoft Samples website, the next slide has a few links here, has one demo about QTA. So it gives you a sample database and a sample workload for you to run through the QTA process and see exactly what improvements it finds. So I just wanted to give you a quick modernization tools breakdown of what you've seen today. You've seen DEA, DMA, and QTA. DEA is for A/B testing. It allows you to capture and replay the workload. In earlier versions, it used dReplay. In the latest version, it does not use dReplay. Well, it can optionally, but the default is to use retrace. It can also report on migration blockers because of failed T-SQL syntax, and we've seen a couple of examples of that. DMA is a readiness assessment in itself. It will find blocking issues, breaking changes, behavior changes, and it can do so both in the static scheme of the database and in ad hoc workload in the latest version. It allows you to move the schema and data and some uncontained objects like logins to Azure SQL Database, or if you're moving to another SQL Server, it allows you to backup and restore there. Keep in mind that this keeps the same source DB compat level as it should. It can optionally provide you new feature recommendation like column store or in-memory OTP. And the QTA tool, this latest one, will allow you to, when you're ready to upgrade the DB compat from whatever it was to a newer one, it will guide you through that process in a way that allows you to detect potential regressions and fix them. And it will provide tangible recommendations about tuning those queries because it has experimented with those queries, which is another reason that it only picks up select segments. So I want to leave you with these resources here. The migration resources at the top, the database migration guide, go and take a look at that. It is very powerful because, like I said, you choose the source system, the destination system, and it creates a personalized migration guide for you. You also have the links here for the map toolkit, the DMA, and the DEA tools. If you want to know more about compatibility certification, that short URL there, aka.ms dbcompat. I deal a lot with patterns and anti-patterns that may arise in your T-SQL code, and also how to use and some internal information about the QTA tool in that book there, Learn T-SQL Querying. So this is a shameless plug here. And finally, but very, very important is we used to share some time ago a very large list of shortcuts to various obscure points in the documentation that were hard to get to, but they had a lot of very useful information. We have now condensed all of them into a single shortcut. So it's very easy to remember. aka.ms, WAC SQL shortcuts. And you'll get to a lot of good information about a number of aspects of migration, but also the SQL Server engine itself. So hopefully this was useful. I have already shared the slide deck, and that was actually in the cover. So I'm going to go back there. If you go to aka.ms WAC Tiger Toolbox, under the sessions folder, you'll already see the slide deck that I've used today. It's a PDF, but the links all work, so you can start leveraging that. So hopefully this was useful. Thank you for all the people that remain until the end, and I'll see you next time.
Excellent. Thank you so much, Pedro. Do you have some time for a couple of quick questions?
I do, absolutely.
Excellent. And you managed to answer one of them, because one of the questions was, can we get a copy of the presentation? So thank you very much for that. I have a question. Can you set an Azure SQL database to compatibility mode 150 from the GUI, or do you need to script the change? The GUI does not list 150 as an available
150,
mode.
you have to do it. You have to do it with T-SQL statement. Yes.
Nice one. Thank you very much.
So, but just to add a bit more information there, 140 is still the default for a new Azure SQL database that's created now. We have not bumped the default 150 yet. That will happen roughly around the time that we release SQL 2019, because we usually tend to synchronize those moments in time. But you can set it manually right now.
Nice. Thank you. And can the inventory assessment phase be automated? Because sometimes these assessments can be quite long running.
The map toolkit? The map toolkit supports command line, so yes.
Excellent, thank you. What is the difference between the 2016 Upgrade Advisor and the DMA tool? For migrations to SQL Server 2016, which of the two should we use?
We have not issued the Upgrade Advisor for years now. We actually we discontinued the old Upgrade Advisor back in 2012, if my memory serves me right, and we have taken all that IP, all that code was brought into the DMA assessment and then incremented upon. So yes, you should definitely use DMA and its assessment capabilities.
And sorry, I read one of the questions wrong before. The DMA, can the DMA part of the upgrade process be automated?
Yes, it supports all of these tools that you've seen here, especially the DMA tool and the DEA tool, can be automated. Yes.
Excellent, thank you. When we use the DMA tool, does it consume resources in our source SQL Server instance? Could it cause database or tables to be locked?
Very, very good question. So in its schema assessment, it connects to the destination database or set of databases, and it goes through metadata, which means system tables and DMVs. In that perspective, the potential of creating any blocking is very low, but I would imagine that if you're running in a high-end server that has a throughput of 5-digit transactions per second or more, so if it's already CPU bound and it has a lot of concurrent accesses, it can generate some blocking. I would imagine so, although that's not the experience that we usually see. In the part about the trace itself, now this is a client tool, so hopefully you would be running the DMA tool not inside the server, but in your laptop or desktop or in some other server that you use for testing, right? The trace analysis occurs locally, and it does not replay the trace, unlike DEA that would need to replay the trace. DMA does not replay it, so therefore it will consume resources in the local machine that you're running DMA for the fact that it needs to digest and then analyze the trace itself.
Brilliant. Well, look, Pedro, thank you so much for taking some time out to do the session. Really appreciate that. And yeah, have a good rest of your day. Thank you very much.
You too. Thanks, everyone.